Hello, everyone. Thank you all for coming here, and thank you for giving us this opportunity. I'm here to talk about Demens AI. I'm Abhishta, a co-founder and the CSO for Demens AI. I have a background in autonomous systems masters at DTU, where I focus specifically on explainable AI. And I've always had like a interest in AI since I was very young, and I always used to meddle with things and used to learn a lot about AI, and I really loved that. And I thought that it would be perfect for actually developing something that Demens AI is developing, which goes well societally as well. It has a huge impact societally as well. All my skills that I've learned, and I can keep learning in this environment, and that's why I want to continue doing helping and build Demens AI.
So, hi everyone, I'm Lauren. I'm co-founder and CTO of Demens. So, I come initially from France. I came here 2 years and a half ago for my master in human-centered artificial intelligence, and the story of Demens actually started in a entrepreneurship course here in DTU, where we got the general topic of early detection of dementia. So with my interests into machine learning, my engineering mindset, I dive into the research about how can we actually detect dementia earlier, what do we use, what are the researchers doing in this field. I found a speech was actually useful, and this is how we started the story of Demens AI as a startup.
All right. So I'd just like to introduce you all to actually what is it that we'd like to talk about today. So first, introduce you to what is it that Demens AI does and what is it that we want to do. And we'll give you some tech insights about how we do it. And also, Lorene will present some results about what we have done so far. Right? So let's start. I'd like to highlight the fact that dementia is the fourth most leading cause of death in Denmark and the seventh in Denmark. It affects 55 million people worldwide. And this number is expected to increase by over 2.5 times by the year 2050. And this is mainly because improvements in medical technology, which leads to having higher life expectancy for all the people, and dementia becoming more risk because we're living longer as people. And that's why we spoke to neurologists and neuropsychologists from RIS Hospital and Zealand University Hospital. And they tell us that 75% of the cases related to dementia go undiagnosed. And this is a major problem. This is mainly because of inaccurate screening tools. That is a pen and paper test that is developed in the 1970s. So it's called the MMSE, and they still use it, where you just ask some basic questions to the patient to check how their cognition is. Like, what is the date today? What is your, repeat these words that I've said, and other things. So these are very basic, and they also told us that since these are so basic, it's very hard to recognize the dementia specifically in an early stage. So it's very sensitive to it when it's in the moderate or in the severe stages, which makes it very difficult to diagnose early on. And that's why one of the things that they also told us is late detection. After all of this, even though these two are big major problems, they also told us that once they're detected, they're thrown into the diagnostic pathway, which can take over a year sometimes to actually get a diagnosis. And this being a progressive disease is a really big problem. So that's why what we propose and what we noticed is that we could actually use speech, which is very characteristic for cognitive disorders. So there are a lot of speech patterns that appear in our speech, which is very subconscious. And those patterns are very good and recognizable by AI. And that's why we propose a solution where we can use AI to passively listen in on the consultation that you have with the doctor. So imagine a scenario where you basically have some cognitive concerns and you go into the doctor and you tell them about this. So the doctor will first have a normal conversation with you, and then they will provide you with this MMSE test. So once they give you this test, you will be talking to them with the natural conversation that you have. So we use our AI to passively listen in on this whole consultation that you have, and then at the end provide an analysis report that kind of tells you the type of dementia that you might have, or also the severity of that dementia. And we believe that this tool will be more accurate because of our research so far, and also it'll be unbiased, which is again something that we are discussing. So we also can do this because it's passively listening in with normal conversations that you would have about cognition with your family and etc. So back at home as well. And also it would be simple and non-intrusive, so it's not expecting you to do anything extra. So with all of this, uh, why do we choose speech?
So yeah, the question is, why do we use speech? So speech is a interesting window into the brain and into what's happening in our cognition. Dementia actually kills some neurons in the brain, and analyzing speech allows us to understand what's happening in the brain. So the speech provides us with two different modalities that are interesting to analyze. We have what we say, so the acoustic features, and how we say things, so the linguistic content of the speech. So let's first dive into the acoustic features. So let me give you 3 examples of interesting features that we analyze in the speech of people with dementia. These acoustic features that were relevant to distinguish between people with dementia in our analysis Alzheimer's disease and control people. So the first example is the quality of pronunciation. So we found out that people with Alzheimer's disease or dementia, they show a reduced level of articulation and their speech is less clear. One of the second example is the loudness. So we found out also that they show a reduced variability in the loudness. So when they speak for a long time, describing something or talking about a given topic, the loudness shows less variability. And finally, regarding the speech consistency, we found out some relevant characteristics between healthy people and people with Alzheimer's disease. So to measure this speech consistency, we analyzes the spectral flux, that is the energy that you put in your voice and in your speech when you speak. And we found out that people with Alzheimer's disease, they show more spectral flux in their speech and more variations of this spectral flux that leads to less speech consistency. So now let's dive into the other side of speech, that is the linguistic patterns. So when we transcribe the speech into words, what can we find out in these linguistic patterns between people with dementia and healthy people? So again, 3 examples. One of the first one is the noun and pronouns ratio. So when we count the number of nouns and pronouns used by people when they speak, we found out that people with Alzheimer's disease, they tend to use a bit more pronouns than nouns when they speak. The reason why is linked to the memory loss that is progressive as the disease develops. They would tend to use more pronouns to refer to specific objects or referring to people instead of naming them. This is linked to the second example here, the lexical diversity. So with also the loss of memory and the loss of cognition, we found out that people with Alzheimer's disease and dementia, they use less vocabulary words and they tend to repeat more the same words. So as an example, we can mention the books of Agatha Christie. She wasn't diagnosed per se with Alzheimer's disease, but her doctors, they had a suspicion of cognitive disorder. And analyzing the terms used in the books at the end of her life, we find out that she's using less and less specific words, less complex sentences, and she's repeating herself more in the last books of her life. So that's an illustration of the effects of the disease on the words we use. And as the last example, to meet the analysis actually of Lina, we did also some sentiment analysis on the speech of people with dementia. And we found that people with dementia, they tend to be more neutral in their speech and in the terms they use. They have less arousal, so they're less intense in the emotions that they show in their speech.
All right. So now that you all know what is it that's there in audio signals that we can use, so I'd like to show you how we do it. So what we do is we listen to that consultation passively and get an audio signal, which is then provided to a model that gives us the transcript. That's called, and we use an ASR. And once we have the audio signal and transcript, we provide it to embedding models. And these models, you can think of them as the latest AI technologies that try to provide you with complex high-level representations of all of these features. So the features that we have been talking about so far are just some of them, and there are a lot more that are very significant in Alzheimer's and dementia patients. So what these models are good at is pulling out those things and then giving it to the computer representation. So we use these and then put it into a deep learning classifier that will give us all the classifications or all the requirements for that analysis report. So what is it that mainly it would talk about the type of dementia. We are trying to differentiate between 6 types, and then also the severity of that dementia. So this way, once we have the severity, we can actually make sure that people who are more severe are more prioritized because they need to actually be diagnosed earlier to take treatment earlier. And also, if the type of dementia, some of them can also, we need to make sure that the people who are going in, we are sure about the people that we send in. So that because it's already overloaded, we need to make sure that it's not that overloaded. When we send in, it's more likely that they are having dementia. So yes. So using the latest technology here, we use automatic speech recognition models like Whisper and Wave2Vec, and we experiment with them and see which one is the best for our model and which for the specific case. So for Whisper, which provides a transcript for the audio signal, and also Wave2Vec also provides a transcript. But one of the things that we noticed is also that these models are really good at capturing acoustic features. So these models are meant to actually take your acoustics and convert it into your linguistics, right? That's what an automatic speech recognition says. So what we try to do is try to take that model, the point of the model, which basically takes the most understanding of acoustics, and take that out, put it into our classifiers. Same way, now we have a transcript, which as she mentioned about the language that you use is very descriptive about dementia. So when we use the transcript, we basically use large language models like BERT. BERT is very good for sentiment analysis. Falcon and GPT, which are new latest models of LLMs, which basically tell you more about how the structure of the sentences are, which was the semantics as well, because that's also very specific. And these type of things are all captured in these LLMs, and we take the one that has the most amount of information in them. And we take that and provide it as the input to the classifier that we experiment, we train, and with the latest structures. And we train completely from scratch. And yeah.
So to mention a bit of our research and results, so this is a study we performed on research data that is available for research communities. So this is in English. We have 166 samples of picture description. So 50% of this data set are diagnosed with Alzheimer's disease, and the rest is healthy control. And these people were asked to describe this picture that is called the cookie theft, and that is actually already used in language impairment detection for aphasia detection, more specifically. So these people provided something like 2-3 minutes of speech sample. So we have 166 for training and 71 participants for testing our AI on that. So even though this dataset is quite small regarding all of the data that was used for training these big models, we could still reach very nice performance. So this is the performance we reached on the test set, so the unseen datasets. We reach an accuracy of 93% on the test set, specificity of 97%. So the specificity refers more specifically to the confidence level of the model to say to someone that this is a healthy person. And the sensitivity that is here, 89% that we reached, this is referring to the confidence of the model saying that a person has Alzheimer's disease. So these results, we've been talking to neuropsychologists and doctors, and we've been told that this is the performance they're looking for and is better and as good as the current test they have at the GP level, so at the doctor. And finally, this is a visualization of our prediction with the test that Abby mentioned before that is already used at the doctor. So this MMSE score is from 0 to 30. 30 refers to a healthy cognition, and it decreases as the dementia diseases develop. And we have on the x-axis our score, so that is our probability to get an Alzheimer's disease diagnosis. And here we can see that the correlation of the MMSE score with our prediction is quite good. And also, this allows us to understand how far people are progressing, and we can do some regression by giving a probability, but also with this 50% split, we can classify people in one disease or one another.
Yeah. So if you want to know more about us, please do get in touch. We're right now looking for people to help us out, interns, thesis students, to help us out and develop more of this in terms of AI and also about the front end. So if you have any other questions, we're more than happy to answer. Also, we're looking for investments, and if there are any investors out there want to know more about us, please reach out. Thank you.
Thanks.
Thank you so much for a fascinating talk. Hopefully there are some investors either here or online. I see some hands. Maybe it's questions and not investments, but we'll take them.
Yeah, question, unfortunately. How do you set the individual baselines for the individual participants? So, for example, with vocabulary, some people just have a much, much larger vocabulary than others. So where's the starting point baseline for your assessment?
Yeah. So that's a really good question. So the idea is not to set baselines on specific parameters, but to analyze everything as a whole. And that's why we use these large language models, which are good at actually not just saying that they've been trained on millions of samples. And because of that, the distributions are more Gaussian than extreme cases. So it handles well for extreme cases, but there are, of course, chances where if you give like someone who is really, really good at the language and comes in, there are chances that it would be a little less probable that it would detect it early. But that's only in very extreme cases. And usually you would not see that because as you grow older, it also happens that you would have cases where previously they would have come for tests and we could use that as reference.
And to answer this question also, the level of education is already used in the MMSE. It's an actual question. And the MMSE is weighted based on the level of education of the person. So in our case, we're considering having this as a data that you give to the model to teach the model. This is speech linked to this level of education. Yeah.
Thank you. So I've got two questions. So the first one is, do you foresee this tool to be used by neurologists as a diagnostic aid to what they are already using, both subjectively and MMSE and other scores? And then the other questions, can you hear me?
Yes.
Yeah. So, and the other questions is about the regulatory aspect.
Yes. Yes, it is so we want to be a medical device and we would be classified as a class 2A because of the assessment that we have been gotten. So that would mean that we are a suggestive tool. So we give the analysis report and the doctor has the final say, and it's not us making the decision per se. And in terms of regulatory, yes, we're planning to get CE certified so that we can be in the clinics and actually be used with the MMSE.
And part of the claims you mentioned also about you can diagnose different states. Mm-hmm. Will it be between, for example, mild cognitive impairment to vascular dementia, or is it just the grading of the impairment?
So for now, what we are trying to do with Zealand University Hospital is we've launched a 3-year study. And in the study, one of the main goals is to actually differentiate and see what is it that the model can actually differentiate between. So it's also a research claim. So it would not be that we are claiming that we can do this. It is more about the fact that it is possible and we need to actually show evidence that it is possible. And that's what this 3 years will be for.
Mm-hmm. Thank you.
Yeah.
And we have a couple of questions online, and then I'll come down here.
All right, that's lots of applause for you as well. There's all these clapping hands popping up on my screen. The first question comes from Stella Grasshoff. Do you have an estimate of how much data recordings you need for a good prediction? And what length of audio signal have you used so far?
Okay, that's a really good question. And of course, we would always say that for fine-tuning large language models and for Whisper and all of these other models that we're using, experts also claim that you need around 1,000 to 1,500 samples minimum, but that's very difficult to get in terms of clinical data, especially in terms of speech for this specific task. So what we are trying to do is also, as she had asked also, it's a research study, plus it's also a study to actually collect the data that is required for this. And we want to scale that. And right now, we have the model that we showed you right now here is for about 2 minutes of speech. And it's able to do as well as the MMSE, which is around 20 minutes. So it's able to get that much information within 2 minutes. And that's what makes it a very interesting case, because you could take the whole consultation and then how much more accurate would it be?
So are you aiming towards getting 1,500?
Yes, I mean, I'm not putting a concrete number on there, but yes, towards high, above thousands, and more samples, always the better.
Can I have another one? So Anders Bargum asks, he's interested in hearing more about the choice of using passive listening rather than a task-based approach. He says, I can imagine that it would give a more controlled scenario if you have a task-based approach.
Yes. Yeah.
Does that make sense?
Yeah, and that was actually the goal. Initially, we didn't want to stick to the MMSE or what is done. We had our own questions, but as we talked with doctors, it's actually very hard to make them change the way they process the consultation. And since our goal is to be a tool used by the doctors to help them doing the diagnosis, then we need to stick to what's happening already and to guide them towards the use of AI and something slightly different in the future. So we need to stick to what they do. So
again, for passive, it was also, as she mentioned, it's also easier for someone like consulting to not change their process and just click a start button and then click a stop button. So in terms of usability, it would be a lot easier this way, and then put all the effort onto us instead of putting the effort onto them to change their processes. Yeah.
Okay. Last one from Lena Scarrett, and then I'll give the word back to the room here. She asks, do you know how well it works on non-native speakers?
Yes. So right now we have to, so for each and every language, it has to be separately trained. And that's also why I asked the question about biases, because then we are also exploring how these biases will affect the model. And the idea is that if we can provide the data equally between all the cases, then yes, we could train the model that way. But it is very hard to say how the model will perform until and unless we have a full-fledged data set that can, and then analyze the biases and then accordingly tell you. Because one of the things that we need to do for regulatory, being a class 2A medical device, is that we need to show them these risks and biases, saying that, okay, this is the risk that we face in the sense that maybe a minority community from Jutland will face a difficulty, whereas a minority community from Copenhagen won't face that much of an issue. So, yeah.
Yes, can you hear me? Great. Oh. Hey, I wanted to thank you for the talk. I think it was very well presented as well. I wanted to say that. Very curious about this suggestion, and I'm curious, especially since you said one issue is that a lot of cases are being missed. So I'm wondering, without being an expert in this field, of course, doesn't that also mean that a lot of people that are being missed, that actually until they get to that moment where they sit in the chair in front of a doctor that, you know, is having the intention to diagnose something or you know, the opposite. So do you see some potential for your solution to help people until that point in time, like to prompt people to the possibility that they may have dementia or Alzheimer's? And maybe there's some potential you see with your current setup where you could tweak it, or the limitations of data availability doesn't allow for it, or just hearing your thoughts, I'd be curious. Thanks.
Yeah.
Do you want to go?
Yeah. So that's an actual problem that I faced also, because my grandmother, she had dementia, but she has never been diagnosed. So she's part of these undetected cases. And what we envision, so initially we want to build a strong model in collaboration with the doctors to make it good. And then the goal is to push it in the home setting where you could have the application and talking to your parents or your grandparents to have these tests done as well. But initially, we want to first develop a strong model and then push it for the customers or for the people. Yeah.
Also, at this stage, because as she said, by strong model, I would like to say that it's because of the fact that we would have to analyze these risks, biases, because it's only, we are put under regulations only if we try to go to the clinical setting, because right now we could just go out there, claim anything, and then sell it, but then that's not going to be as valuable to the people if it's going to put stress on them. So, and this is a very sensitive case as well. So that's why we're taking the hard path, essentially, to get sure that we are comfortable in this area, then we're sure to go in the other area much easier. Yeah.
Yes, thanks for the talk. It's very interesting. I would just like to hear about the choice of speech to text model. That was Wave to Vec, and I don't remember the other one, but essentially my question is, I'm interested in like how good these models, like the performance of those, because I've personally tried to fiddle around with them on my dad and on some recordings with him, and it managed somewhat well, but like I would describe it as he had some certain speech patterns that it didn't understand, like pause words that was almost very close to other like words he was saying, so it couldn't pick up what exactly he was saying. So I guess my question is just like, how good are these models, like distinguishing actual what is being said?
So right now with Danish, we have with Whisper, which just trained on about, how many samples was it? It was very small amount of samples, but it's still getting an accuracy of 87%, or 87% of the times it gets the correct word. And yes, of course, it's always a problem, but it's still more information than not having it. And that's the idea. So if we were to ask them to actually transcribe everything, there would still be errors. But it's still going to give us more information than just using the speech signal without any acoustics. Because large language models are really good at understanding semantics. And also, in some cases, if you've noticed, while even if you take the example of ChatGPT, if you make spelling mistakes and stuff, it's still able to understand to an extent. So yes, there are errors, but these errors through the whole process should be accommodated for as we train more. And also, of course, it's a matter of data, which is the biggest challenge right now for us. Yeah.
Cool. I'll say thank you
Thank
for
you.
all of the good questions, all of the good answers.